this is Dilip Udani, Assistant Professor at LJ Institute of Engineering and Technology. Today I will teach you Maclaurin series by substitution. Maclaurin's series by substitution. So I will make you understand this topic with the help of examples. So first example is, we have to prove that tan inverse of x into bracket 3 minus 4x square divided by square root of 1 minus x square into 1 minus 4x square, that is equals to 3 into bracket x plus x cubed by 6 plus 3 x raised to 5 by 40 and so on. Now to prove this result, we have to suppose x equals to sine theta. So let x equals to sine theta. Okay? If x equals to sine theta, then theta is equals to sine inverse x. Now in the left hand side, that is this one, we will replace x by sine theta. So tan inverse of x into bracket 3 minus 4x square divided by square root of 1 minus x square into bracket 1 minus 4x square. So this is equals to tan inverse of replacing x by sine theta. So it will become 3 into sine theta. So the result is 3 sine theta. Then after minus 4 x into x square, result is x cube. So replacing x by sine theta, so it will become 4 sine cube theta divided by square root of 1 minus sine square theta. Then after into bracket 1 minus 4 sine square theta. Okay. Now we have to simplify this result. So this is equals to tan inverse of, as you know, this is the formula of sine 3 theta. 3 sine theta minus 4 sine cube theta, that is sine 3 theta. Okay. Now 1 minus sine square theta, that is cos square theta, and square root of cos square theta, the result is cos theta into bracket, this is 1 minus 4. Now replacing sine square theta by 1 minus cos square theta. Okay. Now we have to simplify this result. So 1 minus 4 1 is 4, so it is minus 4, and 1 minus 4 is minus 3. Then after minus minus plus 4 into cos square theta, result is 4 cos square theta. Now we will multiply 4 cos square theta minus 3 by cos theta. So it will become 4 cos cube theta minus 3 cos theta. Okay. And we have formula of 4 cos cube theta minus 3 cos theta. Okay. So that formula is cosine of 3 theta. Now tan inverse of sine 3 theta divided by, this is cosine of 3 theta. Okay. Now sine 3 theta by cos 3 theta, that is tan 3 theta. Okay, tan inverse of sine 3 theta by cos 3 theta. But we know that sine theta theta by cos theta, the result is tan theta. So tan inverse of sin 3 theta by cos 3 theta, it will be tan inverse of tan 3 theta. Okay. Now tan inverse of tan 3 theta, that will be 3 theta. And theta is equals to sin inverse x. So this is equals to 3 sin inverse x. So 3 will be as it is. Now we will write down the series of sin inverse x, and that is x plus x cubed by 6 plus 3x raised to 5 by 40 and so on. So this is the required answer of tan inverse of x into bracket 3 minus 4x square upon square root of 1 minus x square into 1 minus 4x square, and that is equals to 3 times into bracket x plus x cubed by 6 plus 3x raised to 5 by 40 and so on. Okay, now we will see second example, that is tan inverse of square root of 1 plus x square minus 1 divided by x, that is equals to 1 upon 2 into bracket x minus x cubed by 3 plus x raised to 5 by 5 and so on. Okay. Now in this problem we will suppose x equals to tan theta. So let x equals to tan theta, therefore theta equals to tan inverse x. Now tan inverse of square root of 1 plus x square minus 1 divided by x, this is equals to tan inverse of square root of 1 plus tan square theta minus 1 and divided by tan theta. We have replaced x by tan theta. Okay. Now this is equals to tan inverse of 1 plus tan square theta. The result is sec square theta, and square root is sec theta minus 1 divided by tan theta, and this is equals to tan inverse of sec theta, that is 1 over cos theta minus 1 and divided by tan theta is sin theta by cos theta. Okay. Now we have to simplify this result. So tan inverse of, now we will find out LCM in the numerator, that is cos theta. So this is going to be 1 minus cos theta divided by cos theta. Then after sin theta by cos theta. So cos theta will cancel out. So it is tan inverse of 1 minus cos theta over sin theta. But we know the formula of 1 minus cosine of 2 theta, right? That is 2 sin square theta. So the formula for 1 minus cos theta is 2 sin square theta by 2. So this is equals to tan inverse of 2 sin square theta by 2 divided by formula of sin 2 theta, that is 2 sin theta cos theta. So the formula for sin theta is 2 sin theta by 2 into cos theta by 2. Now 2 will cancel out. Sin theta by 2, sin theta by 2, 110 will cancel out. So it will become tan inverse of sin theta by 2 by cos theta by 2. And sin theta by 2 by cos theta by 2, answer is tan theta by 2. So it is tan inverse of tan theta by 2. And tan inverse of tan theta by 2, the result is theta by 2. So half will be as it is, and theta equals to right? We have, suppose x equals to tan theta, so theta equals to tan inverse x, and this is equals to half, and tan inverse x, that is x minus x cubed by 3 plus x raised to 5 by 5 and so on. So this is the required answer of tan inverse of square root of 1 plus x square minus 1 over x. Okay, now we will see example number 3, that is sine inverse of 2x over 1 plus x square, that is equals to 2 times into bracket x minus x cubed by 3 plus x raised to 5 by 5 and so on. Okay. Now in this problem we have to suppose x equals to tan theta. So let x equals to tan theta. Let x equals to tan theta. Therefore, theta equals to tan inverse x. Okay. Now, sine inverse of 2x over 1 plus x square. This is equals to sine inverse of 2 x is tan theta, so 2 tan theta over 1 plus tan square theta, right? Now we have formula of 2 tan theta over 1 plus tan square theta, that is sine 2 theta. So this one will become sine inverse of sine 2 theta, okay? And sine inverse of sine 2 theta, that is 2 theta. And this is equals to 2 sin, and theta equals to tan inverse x. Okay. Now this is equals to 2 sin, and we have series of tan inverse x, that is x minus x cubed by 3 plus x raised to 5 by 5 and so on. So this is the required answer of sine inverse of 2x over 1 plus x square, that is equals to 2 into bracket x minus x cubed by 3 plus x raised to 5 by 5 and so on. So in this lecture we have discussed Maclaurin series by substitution method. Thank you for watching this video.